Hello students. So today we are going to do composite functions, that is composition of functions. Okay. So say if you have three sets, okay, A, B and C. Now first function is defined from A to B and second function is defined from B to C, that is G function. Okay. Then the composition, that is from A to C, is given by G composite F. Okay. What this means is that there is a x belonging to this. Okay. When this function is there, so A to B, you will get f of x, right? And then this becomes an element in B and we have to find g of f of x. So G composite F of x is nothing but g of f of x. Okay. Similarly, we have a function f composite g, which we write it as f of g of x. That is, you have to find first f of x and then again you have to find g of f of x. Okay. Now this function g composite f is from A to C. Okay. And f composite g is a function from C to A. Okay. So by definition, let f from A to B, f is from A to B and g is from B to C are two functions. Then composition of f and g denoted by g composite f is a function from A to C and it is given by g composite f of x is equal to g of f of x for all x belonging to A. Okay. Let's see some examples. So I'm solving examples from the textbook. Okay. So here they have given f function. It is from 2, 3, 4, 5 to 3, 4, 5, 9. Okay. And g is a function from 3, 4, 5, 9 to 7, 11, 15. Okay. And it is defined as f of 2 is going to 3. A2 goes to 3. 3 goes to 4. Then 4 goes to 5. And also 5 goes to 5. Okay. G of 3 goes to 7. G of 4 also goes to 7. And G of 5 goes to 9. And G of 5 goes to 11. G of 9 also goes to 11. You have to find G composite F. So G composite F will be the function from this set, that is A set 2, 3, 4, 5 to the C set, that is 7, 11, 15, right? So you have to take the values this 2, 3, 4, 5. So G composite F of 2 is G of f of 2. Now f of 2 is 3. So G of 3 and G of 3 is 7. Okay. Similarly, you have to find for 3. So G of f of 3 is 4. So G of 4 is 7. Okay, like this you have to find for all the elements. Let's solve the second example. So find G composite F and F composite G if F is from set of real numbers to real numbers and G is also from R to R, given by f of x is cos of x and g of x is 3x square. Okay, so first thing you have to find is f composite g of x. So f of g of x, g of x is given to be 3x square and f of 3x square is cos of 3x square. Right, and then you have to find g composite f of x, g of f of x, g of f of x is cos of x and g of x is 3x square. So here in place of x you have to put this x, that is cos of x. So cos of x the whole square, that is cos square x. Now this and this terms are not equal, so g of f is not equal to f composite g. Okay. Next question. This is example 17. Show that if f r difference 7 by 5 and r difference 3 by 5 and f of x is given and g of x is also given, you have to show f composite g identity of a and g composite f identity of b function. Okay, so first you have to find f composite g. I'll write here f of x and g of x. Okay, so f composite g of x is f of g of x. So f of g of x is 7x plus 4 upon 5x minus 3 and f of x is this. So wherever there is x you have to put this function. Okay, so 7 3x plus 4 upon 5x minus 7 plus 4 upon 5 into 3x plus 4 upon 5x minus 7 plus minus 3. Sorry, you have to put this function in there. Okay, this is your x now and you have to put this x in this function. So this is 3 into 7x plus 4 upon 5x minus 3 plus 4 upon 5 into 7x plus 4 upon 5x minus 3 minus 3. Okay, multiply, you'll get this, you multiply here and this you can multiply here. So cross multiplying, the denominators will be same, 5x minus 3, 5x minus 3. So you can cancel them. So this is 21x plus 12 plus 4 5s are 20x minus 12 upon 35x plus 20 minus 15x plus 9. Okay, now this is 21x, 20x, so 41x upon, yeah, only 41x will remain. This is 3. This is 7. So this becomes 21. Okay, so this is your and this also changes now 35. Okay, this gets cancelled and we'll get here 41. So this is x. Okay, you are getting x. So this becomes identity. You are getting the same thing. F composite g of x, x. Okay. G composite f also you have to do the same thing. That is, first you have to take g of x. Sorry. G composite f of x is g of f of x. Okay. So g of f of x is 3x plus 4 upon 5x minus 7. So this is your x now, and you have to put this in place of x, you have to put this in g of x. Okay. So 7, 3x plus 4 upon 5x minus 7 plus 4 upon 5 into 3x plus 4 upon 5x minus 7 minus 3. Okay. So denominators will get cancelled. You have to do cross multiplication. So this is 21x plus 28 plus 20x minus 28 upon 15x plus 20 minus 15x plus 21. So same thing you are getting. Okay, this becomes 41x. This is 41. We'll get x. Okay. Next example, example 18. Show that if f is from A to B and G is from B to C are 1, 1, then G composite F A to C is also 1, 1. Okay. So F and G, it is given 1, 1. You have to show G composite F to be 1, 1. Okay. So let's say x1 and x2 belongs to A. Okay. Let f of x1, not f of x1, now we have to prove for G composite F, right? G composite F of x1 is equal to G composite F of x2. Okay. So this is G of F of x1 equal to G of F of x2. Okay. G of F of x1 is, now we know that F is 1, 1, G is also 1, 1. So this is G of some value and G of some value. So this is given 1, 1. So we can write the values are equal. Correct? Again, F is also 1, 1. So x1 is equal to x2. So it is 1, 1. Okay, G composite F. Then next is you have to show that it is onto. Both are given 1, 1. You have to show that it is onto. So G composite F is defined from A to C, right? So you have to take some element from C. Say some element Y, or A to B, we can take X, Y and Z. So Z belongs to C. Okay. Let Z belongs to C. So there exists image X belonging to A such that G of F of Z is equal to, no, X here, G of F of X. Now F of X is given to be onto. right? So we can take this as some y for y belonging to B. Okay, and G is also given onto, so this is equal to Z. Okay, now we have to check vice versa, that is if G composite F is given 1 1, we have to check whether F and G are 1 1. Okay, so they have taken one example, that is F is from this 1 2 3 4 to this, F of X is equal to X, and G is also taken. Okay, so X values are 1 2 3 4 and G values are this 1. Okay, this becomes your A set 1 2 3 4 and C set is 1 2 3 4 5 6, right? But here G is not 1 1. Okay, so if you take G of 5, G of 5 is going to 6 and G of 6 is also going to 6, correct? Because F are only 4 values and here too many other. So this is not 1 1. So it is not necessary that if G composite F is 1 1, then both F and G will be 1 1. Okay. Now here they have taken another example for onto. Okay. Here also the same thing, that is if G composite F is onto, then it is not necessary that F and G are onto. Okay, you can solve this two examples.